In this video, I'm going to talk about the difference between the Taylor, Maclaurin, and Binomial Series and their setup. How are they different and how are they similar? So let's go ahead and take a look at what these look like. So a Taylor series, which we're going to indicate with the T, we have the sum going to infinity. We have f of n of a all over n factorial, and then x minus a to the nth power. So that's Taylor series. Going to Maclaurin, M for Maclaurin, we have something very similar with only one difference. So we have f of n, but our a in this case is always 0 and over n factorial, and this is x to the n. So here there's no need to actually put x minus a because it's always 0 for the Maclaurin series. And then for our final one, which is the binomial series, indicated with the b, this one's kind of the weird one, but they all have their purpose. So same sum, but in this case we have a k over an n, x to an n. So this one does look different from all these, but we're going to go through each one of them and I'm going to explain how they're different and how they're actually quite useful. So starting with the Taylor series. When this gets broken down and term-wise here, you're always going to have f of a multiplied by x minus a to the nth power all over n factorial. This is going to be plus f prime of a multiplied by x minus a to the nth power over n factorial. So the only difference as we keep moving into all the new terms is just we're doing the derivative each time we go. So f of a, f prime of a, double prime of a, x minus a to the n all over n factorial. So moving to the Maclaurin series, you'll notice on this one that it's going to look very similar, but whenever you have 0, or perhaps if it says to solve for a Taylor series but does not give you what it's centered at, we assume it's at 0, so you can just go ahead and use the Maclaurin series. For this one, term-wise, it's going to look like f of 0 plus f prime of 0 plus f double prime of 0, and then this is where we add on our x squared, 2 factorial, plus f triple prime of 0, x cubed, 3 factorial, and this will continue on. So a little different, but this one is a little easier. It's a little less work as far as simplifying. So whenever you have your Taylor series centered at 0, you actually have a Maclaurin series, which is a Taylor series. It just has its own special formula. So for the binomial series, this is usually 1 starting plus k times x plus k times k minus 1 x squared all over 2 factorial plus k times k minus 1 k minus 2 times x cubed all over 3 factorial, and this pattern will continue on as well. So the only difference with this one is you do need to know k. K is your exponent in your problem given, so it's pretty easy to find, and this pattern will continue on, and that's why they do write it in the sum formation of k over n, because it's just easier to write. But something kind of fun about these is this is actually equal to the Maclaurin series. So each one of these terms is actually equal. So I always thought that was kind of fun. So if you ever do have a Maclaurin series, you could probably put it into a binomial series, and those are just some similarities between each of them. The only difference between the Taylor and Maclaurin is you do not have your x minus a, which you technically could write out, but there is no need because x minus 0 will just give you x. So that is why we just do x squared here over 2 factorial. Alright, I hope this video helps a little bit on distinguishing between all three of these. And if you have any questions, please leave a comment and I'll do my best to answer them. And until next time.